So hi, good morning everyone. How are you? So today we'll start our chapter laws of motion. So basically this is very important chapter in the kinematics and we are going to see many different concepts which you didn't learn till now I think. Okay. So if you are preparing for JNE, this is for you. Okay. So the first heading we are having in the laws of motion is called force. So after force, we will go in the after that Newton's laws of motion like NLM, okay, and after that we'll see FBD, free body diagram. So that's our today's plan basically. So let's start then. So the first topic we are having it force. See, in the nature we have different type of forces. Some internal forces are there, some external forces are there. Let's say in a body, whatever inbuilt inside there is a reaction is happening, or we can say some internal agent is there which is applying any cause of motion or state of it's changing the state of the body. That's called internal forces. Same as external forces, we are just changing the state of motion by applying outside any agent or any we can say we are applying some forces. So these two type of forces we are having. In general, we'll use some forces. I'll write the names. Okay, just say like tension. Let's say so tension and spring force. Okay, weight force, normal force, normal force, friction force. So these are some basic forces which we are going to use in this chapter. So most probably our focus will be on spring, tension, weight, normal and friction force only. And whole kinematics will be over, you will see. Okay. So one by one I can give some basic we can say analogy what is tension. Basically tension whenever there is a string we have applied a mass, let's say कोई भी string है उसके ऊपर कुछ भी mass hang कर दिया. Now what's happening, that hanging mass is creating a taunt in the spring, we can say that's a tightness is called tension. Okay, that's represented by T. We'll see in the depth, no problem, when we'll do the questions. Okay, next we are having spring force. In the oscillation chapter I think you have studied what's the spring force called. F is equal to minus kx. Remember, when we stretch the spring, either compress the spring, it will try to oppose the motion. Okay, whatever we are trying to do, let's say we are compressing the spring, what will happen? It will try to go back in the original shape. If you are stretching, it will again come back to original shape. That type of force, which is opposite to the displacement of the body, that's called spring force. Next, we are having weight force. Weight force is represented by W, and the value is mg. Weight is a force which is caused by the gravitational field of the earth. We can say gravitational acceleration, okay, which is g. So mg is the force value. Now normal force is represented by normal n only. I'll show you how it is working. Friction. So frictional force you already know. I think F is equal to mu into n. Mu is equal to frictional coefficient, n is normal reaction. Okay, these things we already know. Basic things. In depth, we'll see the friction in a particular part of this laws of motion. Now, we are moving ahead to the topic which is called NLM, Newton's Laws of Motion, in basically laws of motion chapter. Okay, so this topic means there are three laws of motion. So I'll start by one. See the first law. Newton's first law of motion is also called as the inertia law, or either law of inertia also you can tell. Now, first of all, what is inertia? See, a pen is there. This pen will be in rest. Let's say I put it here. So after putting here, this pen will be in the hand only till infinite time, till when I don't apply any external force. That inability to change the state of the object is called inertia. See, so how you will write it? Simply, if a body, I'm writing a definition. If a body uh, is in is in rest or in motion, okay, whatever it can be, either it can be in rest or motion, either in a direction particular. So it will be same. It will be same. Okay, until unless we don't apply any external force. So that is the definition of we can say our first law of the Newton's first law. So you can remember only one way, like whatever body, if that is moving, it will be move in motion only. If it is in a particular direction, that direction will be same. If it is in rest, that should be in the rest only, till when we don't apply any external force. Now I am giving example. Let's say I am sitting in the bus. Suddenly bus is turning. Suddenly bus turned on a, we can say, turn. What will happen? We also try to go outward from the bus. Let's say bus is turning this side, we will go that side. Why? Because of the inertia, our original motion towards this direction, we suddenly bus driver change the direction. So what will happen? Our inertia, we can say, inability of that our body, that will be same. Okay, you can say inertia ko we can define as inability also. Another word, in one word, if you want to define inability. Okay, so what I was explaining, the example you can write bus. Okay, bus turning on a turn. Okay, so when it turns, what will happen? I already told you. Let's say we are moving in a bus or train. Suddenly brakes are applied. After applying the brake, what will happen? We are feeling that we are in forward direction, like a pulling force is there, कि automatically हम आगे की तरफ झुक जाते हैं. Why? That is because of the inertia. Okay ना, because our body wants to be in the motion continuously. Suddenly brakes are applied, because of the external force, our motion, we can say, disturbed. So that type of things are in the law of inertia. In that we can say three four states are there, like inertia of the rest, inertia of the motion, inertia of the direction. So three types of inertia we have. We don't need to go in that much depth. That's the basic part of the law of inertia. Second law. Okay, so before the second law, I want to explain one topic, which is momentum, because in that Newton's second law we need this term. So now if you don't know what is momentum, simply momentum is the quantity of motion. In one word, if you want to say quantity, okay, quantity of motion simply. So momentum क्या होता है? Quantity of motion, like how much fastly a body is moving, or how much slowly, how much motion it is carrying. That's we can say by the momentum. The formula or the definition is very simple: mass into velocity. Now it represented by P, we can say P, and the value will be equal to mv. Okay, this is in vector form also available. So P vector is equal to m into v vector. Now what's the dimension here and unit here? So unit के लिए simple सा logic, m का unit कितना होता है? kg into velocity meter per second. And if you want to write dimension, that will be equal to m1 l1 t, you can say, minus 1. So this is the dimension of the momentum. Okay, after that we are going to see second law of motion. So now we are having Newton's second law. In that, what we'll explain, see, that according to Newton's second law, on a body, if it is moving, let's say with v velocity, after some time the velocity is increased or decreased, the change in momentum, the rate of change in momentum will be equal to the force. We can say directly proportional to the force. The definition is like that. So I'm writing it. See, the rate of change of momentum is directly proportional to proportional to net external force. That's the definition of this second law. Now what's happening here? Rate of change. Rate means with the respect to time, something is changing, change of momentum. So basically you can write delta P over delta T. And if the momentum change is very small, with we can say time period is very small, then you can write it as dP over dt also will be proportional to force, external force. That is called second law of motion. After this, we'll if you'll remove the proportionality sign, we'll get a constant. Okay, both side you can apply vector if you're writing vector form. So it will be constant is equal to 1 only. Okay, so we are having f only. Okay, directly. Now, if we'll solve this further, what we'll get here? See, so इसको थोड़ा सा आगे solve करते हैं. See, f is coming as dp over dt. What is the p value? Just now we have seen what is momentum, p. is equal to we can say m into v. Okay, two things are there. One is the mass, another one is the velocity. See, so d over dt into mv. Now if we'll consider mass as the constant term, okay, we have two cases now. Okay, I'll tell you. Mostly cases, mostly cases our velocity is going to be changes, okay, not mass, because body mass can't change suddenly. In the one case, let's say rocket case, their velocity and mass both will be changing. Okay, so I'll tell you here.